Hello and welcome to episode 3 of Winners and Losers. Now, it was way back in 2014 that I started this series, and a lot of people have been requesting that I continue it, so I decided to do just that. So thank you to everyone who suggested the topic. Planets. Well, the 8 planets of our solar system anyway. I will not be including Pluto because it's a dwarf planet which is part of the Kuiper Belt. Anyway, doing planets as a topic for Winners and Losers is quite a bit different from episodes 1 and 2 because most of the categories I looked at don't really apply here. Anything involving population or the economy, for example, are only applicable to Earth. Now, one thing I can do, same as the first 2 episodes, is start by looking at size. Now, the planets can be grouped into 3 categories: terrestrial planets, gas giants, and ice giants, with the largest obviously being Jupiter. So just how big is Jupiter? Well, Jupiter has a diameter of nearly 143,000 kilometers, about 11 times that of Earth. Its equatorial circumference is 439,000 kilometers. This is a greater distance from the Earth to the Moon, which took the Apollo 11 spaceflight more than 3 days to complete in each direction. If it were somehow possible to fly a commercial airliner jet around the planet without stopping, it would take 488 hours to circumnavigate. That's more than 20 days. In a parallel universe where Earth were the size of Jupiter, the largest country, Russia, would be more than 2 billion square kilometers, or about 4 times the surface area of the actual Earth. Vatican City on Jupiter would be, well, actually still pretty small at just 55 square kilometers, and actually still smaller than the other of Italy's enclaved countries, San Marino, at 61 square kilometers. The small island nation of Haiti would be larger than Earth's India at more than 3.3 million square kilometers. Driving from Land's End to John O'Groats, the 2 extreme points on the island of Great Britain, would take 176 hours to drive by car. A flight across the Atlantic from London to New York would take 77 hours. If this imaginary planet had the same population density as Earth, its population would be 896 billion. Now, of course, Earth as a whole actually has a pretty low population density, what with all the ocean and the fairly empty countries like Canada and Australia. So what if this planet had a population density of somewhere like Monaco, one of the most densely populated areas in the world? Well, such an absurd planet would have a population of 1.3 quadrillion, or about the population of 180,000 Earths. Looking at the planets by volume and comparing the largest and smallest, Jupiter is 23,500 times the volume of Mercury. If we visualise this in terms of liquid, if Mercury were this tiny serving spoon of water, Jupiter would be nearly 60 litres. Not only is Jupiter huge though, it's also massive, and by that I'm referring to its mass. Now, the list of the planets by size and by mass is almost in the same order, except for one difference. Uranus and Neptune in 3rd and 4th places are switched. This means that although Uranus is larger, Neptune is more massive. This is due to it having a higher density than its neighbouring planet. Once again, Jupiter is the most massive, while Mercury is the least massive. In fact, Jupiter is so massive that it has about 2.5 times the mass of all the other 7 planets combined. But despite being so massive, it's almost nothing compared to the Sun. The Sun makes up 99.86% of the mass of the entire solar system. Jupiter is about 1,000 times less massive. Looking at the opposite end of the spectrum, at the smallest and least massive planet in the solar system, Mercury, the closest planet to the Sun has a circumference of 15,329 kilometers. This is almost exactly the same distance as the world's longest non-stop commercial flight in history, Singapore Airlines Flight 21 from Newark to Singapore in an Airbus A340, taking just under 19 hours. So if Earth were the size of Mercury, it would be possible to circumnavigate the entire planet in a commercial passenger airliner jet without stopping. The drive from Land's End to John O'Groats would take just 6 hours, and the flight across the Atlantic just 2 hours and 50 minutes. The population of said fictional planet would be just over the 1 billion mark. Mercury's Russia would be 2.5 million square kilometers, still pretty big to be fair, but 3 orders of magnitude smaller than Jupiter's Russia. Now, Mercury's Vatican City, as you can imagine, would be pretty tiny at just 0.065 square kilometers or 65,000 square meters. That's about 16 acres, or between 8 and 10 football pitches depending on the exact dimensions of the pitch. You could fit 52 of these Mercurian Vatican cities into New York's Central Park. Okay, back to reality now with the planets back to their actual sizes. Of course, any image like this which shows the planets with their relative sizes to scale, it's important to remember that the distances between them are not. This is what the distances between the planets look like, but now the sizes are not to scale. Attempting to show the solar system with size and distance to scale on a YouTube video is literally impossible, because all of the planets would be smaller than the size of a single pixel. This is due to the distances between the planets being so vast relative to the actual sizes of the planets. For example, the distance from the Sun to the Earth is 12,000 times the diameter of the Earth. In fact, attempting to make a scale model of the solar system in any context is extremely challenging. However, despite this, it has been done several times. The world's largest scale model of the solar system is in Sweden and spans the length of the entire country. The Sun is represented by an indoor arena called the Ericsson Globe in Stockholm. An acrylic model of Neptune with a diameter of 2.5 meters is located in a small town some 229 kilometers away. Alright, that's enough about size and mass. Let's move on and look at the planet's rotational and orbital periods. That is, the time it takes each planet to rotate around its own axis and to orbit the Sun. So here's a list of the 8 planets with their days and years. Now, a couple of things might jump out at you for being a little bit odd. The first thing you've probably noticed is that a day on Earth is equal to 0.997 Earth days. So how does that make sense? Well, for this we need to understand the difference between a solar day and a sidereal day. All of the numbers in this table represent sidereal days, i.e. how long it takes the planet to complete one revolution around its own axis. However, a solar day is how long it takes the Sun to reach the same point in the sky relative to that planet. On Earth, this is our day. This is exactly 24 hours by definition. However, a sidereal day is actually about 4 minutes shorter. The reason for this is that the Earth has to spin very slightly more than 360 degrees around its axis for the Sun to be in the same position, due to the Earth having moved about 1 degree around its orbit. This extra rotation is how we get the minor difference between a solar day and a sidereal day. The difference is even more minor for the gas and ice giants, whose rotational periods are very fast and orbital periods very slow, meaning the difference is negligible. However, for the 2 closest planets to the Sun, the difference is quite considerable. Now going back to the table again, and you might have noticed Venus. A day on Venus is actually longer than its year. It takes more time for Venus to complete one revolution around its own axis than it does to complete one orbit around the Sun. Of course, this is referring to a sidereal day. A solar day on Venus is about 116 Earth days. Now what makes Venus especially interesting is that Venus is the only planet in the solar system that rotates clockwise when viewed from above, known as retrograde rotation. That is, it rotates the opposite way from the Earth. This means that on Venus, the Sun would rise in the west and set in the east. Going back to the initial table one more time, and you might also notice the length of the years related to the planet's distance to the Sun. You'll notice that the further away a planet is from the Sun, the longer its year is. The reason for this is Kepler's third law of planetary motion, which states that the square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. The semi-major axis, in simple terms, can be thought of as the long radius of an ellipse. Using p as Earth years and a as astronomical units, the distance from the Sun to the Earth, the equation is simply p squared equals a cubed. Plotted on a graph, we can see the relationship between the distance from the Sun and the orbital period of all the planets. Now, since we know all of the planets' orbital periods, we could therefore work out how old a person would be on other planets compared to on Earth. A year is the time it takes a planet to complete one orbit around the Sun, so for example, a person born and raised on Mars, on let's say the 1st of January 1990, would be about 15 years old today. On Mercury, 116 years old. On Jupiter, less than 2.5. And on the other 3 giant planets, such a person would have yet to have even completed one single year. Well, unless you're watching this video after the 17th of June 2019, which is when the person's first birthday on Saturn would be. Now moving on to the next category, moons. It probably won't surprise you to learn that the planet with the most moons is Jupiter. It has even been referred to by some as its own mini solar system with so many natural satellites. Now just how many moons Jupiter actually has is more difficult than you might think. The latest number is 69 moons, with 2 more having been discovered just this year. So the number of moons that Jupiter actually has is changing all the time and may be different depending on when you're watching this video. The 4 main moons of Jupiter are Io, Europa, Ganymede and Callisto, collectively known as the Galilean moons, and are by far the most massive of Jupiter's moons. In fact, their combined masses make up 99.997% of the total mass of Jupiter's moons. Now Ganymede is the largest and most massive moon in the entire solar system, having a radius of about 40% that of Earth, and is actually larger than the planet Mercury. In fact, Mercury doesn't even make the top 10 for the largest object in the solar system. Saturn also has a moon larger than Mercury, known as Titan. The largest moons in the solar system are mostly dominated by the Galilean moons of Jupiter, but Earth's moon actually comes in at number 5, with Neptune's largest moon coming in at number 7. Although our own moon is only the 5th largest, it's actually the largest proportional to the planet that it orbits. Anyway, like I said, Jupiter obviously has the most moons and the largest moon. Saturn comes in at a close second with 62 moons and also the second largest moon, then the 2 ice giants in 3rd and 4th. There are only 3 moons among the 4 terrestrial planets. Mars has 2 and of course Earth has just the 1. Venus and Mercury have none. To end this video off, I'm going to look at axial tilt. This is the angle of difference between a planet's equator and its orbital plane. You may already be aware that Earth is tilted at about a 23-degree angle relative to its orbit. This is thought to have been caused by a giant impact about 4.5 billion years ago, which tilted the Earth, and the debris from the collision became the moon. This axial tilt on Earth is what causes us to have different seasons. Now Earth is not at all unique in this respect. The planets can be grouped into 3 categories when it comes to axial tilt. Firstly, there's Mercury and Jupiter. These are the most normal planets, with only a very slight tilt. Then next we have the planets that have a significant tilt like Earth. So here we have Earth, Mars, Saturn and Neptune, which all have a 20-something degree angle. Then finally we have the oddball planets, Venus and Uranus, both of which are pretty strange. Earlier in the video, I mentioned that Venus rotates clockwise and is the only planet to do so. Its axial tilt is 177.4 degrees relative to its orbit, which can also be thought of as 2.6 degrees retrograde. Basically everything in the solar system rotates and orbits anti-clockwise, including the Sun, so Venus certainly should rotate anti-clockwise too. It's not exactly known why Venus is the way it is. It's possible that it was caused by some kind of cosmic collision similar to Earth, or more recent hypotheses have suggested that the planet's rotation may have been slowed and eventually reversed due to the tidal effects of the Sun and other planets. Now there's Uranus, which is arguably even stranger. Uranus has an axial tilt of 98 degrees relative to its orbit, which can also be defined as 82 degrees retrograde. This means that Uranus actually rotates on its side. Uranus has an equator which is roughly perpendicular to its orbit. This means that during the northern hemisphere summer, around the North Pole would be the hottest part of the planet, and the sun would be visible all the time, with the rotation of Uranus not having the same day-night cycle effect that we have on Earth. Again, it's not fully understood how exactly this happened, but again, it may have been a giant impact. Well, that's all for episode 3 of Winners and Losers. I hope you enjoyed it and feel free to leave your suggestions for episode 4. Now this episode is brought to you by Squarespace. Whenever you need a domain, website or online store, make your next move with Squarespace. Get a unique domain and create a beautiful website. Start your free trial today at squarespace.com and use offer code WonderWhy to get 10% off your first purchase. So thank you to Squarespace for sponsoring this video, and thanks to you for watching.